Okay, lesson 30, linear systems in 3. It actually should be 3 variables. I mean, we're going to have 3 equations sometimes, but we will always have 3 variables. See, here we only have 2. So determine the value of x and y in the following systems of equations. With this one, we could use substitution, we could use elimination. It doesn't matter to me. You're going to learn what you like better. This one right here, I see that I have a y all by itself. So, well, not by itself, there's no coefficient in front of it. So I can solve for y and plug it into the first equation and get my x. So 2x plus 3, and instead of y, I'm going to substitute 3 minus 2x equals 7. 2x plus 9 minus 6x equals 7. Collect like terms. Here I have negative 4x plus 9 equals 7. I'm going to subtract this way and add this way. So here we have x equals 1/2. I'll say this right now, and I'll probably say it a few more times. You're going to want to watch what you do in this section, because one itty-bitty little mistake is going to throw off a ton of work. And sometimes if you can't find your mistake, you're erasing and starting all over. I almost wore some holes in my paper as I was doing this homework assignment. And then we have our answer, 1/2 and 2. That one was pretty simple because there were only 2 equations. Let's try one more for 2 equations. I'm going to push pause on this one. I think you guys can try it on your own. And I'm actually going to solve it with elimination, not substitution. So we'll see if that works. If you'll see with elimination, I multiplied this second equation by 2 and rewrote it right here. And then I added the 2 equations together. 5 plus negative 4, those cancel out, and 4 plus 4. I got 8. Plugged 8 in for one of the 2 equations. It honestly doesn't matter which one. And got y equals 18. Okay, here's a word problem. And these word problems are so common. I actually went through the same word problems with my Algebra 1 students just last week. So a scientist wants to create 120 milliliters of a solution that is 30% acidic. The scientist has access to 20% solution and a 45% solution. So she's going to dilute the 45% solution with 20%. How many milliliters of each solution should she combine to create the 30% solution? So basically we have a 25% solution and a 20% solution and a 45% solution. We're trying to get so much of one solution plus so much of the other is going to be a total volume of 120 milliliters, but we need to figure out how much of each. So we have to account for the strength of the solutions and the strength of our final solution. And that's how we get it. Okay? So let's go ahead and solve this system of equations. I'm going to solve one of these for y and plug it in. So 0.2x plus 0.45 times 120 minus x. I have 0.2x plus 54, I don't know why I wrote a 0, plus 54 minus 0.45x equals 36. Let's go ahead and collect like terms. 0.25 minus 0.45 is negative 0.2x. 36 minus 54 is negative 18. And my answer is I need 90 milliliters of the 20% solution. Y is 120 minus 90, so I need 30 milliliters of the 20% solution. So 30 milliliters of the, 30 milliliters of the 45% solution and 90 milliliters of the 20% solution. And that'll give me 120 milliliters of the 30% solution. Okay. Here we're starting to get into the three equations with three variables. And we're all going to tackle these different. There's really no way to teach it other than you can watch me do one and then just dive in to try to tackle your own. I'm going to do all of these by elimination. I find it's easiest with three equations and three unknowns. So I hope you can follow along, and I'm going to try to show my work as best I can. So first thing, I'm going to number these, equation 1, equation 2, and equation 3. And then I'm going to sort of tell you what I'm going to do. So first, I think I'm just going to take equation 1 and add equation 3. So 2x plus 3y equals 5. Oh goodness. I have to get my head on straight if I want to get through this lesson. 2x plus 3y minus z equals 5, and x plus 4y plus z equals 12. So add those together. I have 3x plus 7y, the z's cancel, equals 17. Now I think I'm going to take equation 2 plus equation 3. So 4x minus y minus z equals -1, and x plus 4y plus z equals 12. Add those together, I have 5x plus 3y, z's cancel, equals 11. This is pretty cool. I have two equations with two unknowns. I actually think I'm going to tackle these next, because that'll give me an x and a y pretty quick, and then I can find a z. So let's do 5. So we're going to label this equation A and equation B. So let's go 5 times equation A and subtract 3 times equation B. So 15 plus 15x plus 35y equals 85. I'm going to subtract 3 times equation B, 15x plus 45y equals, I did 3 times 11. So 15x minus 15x cancels, 35 minus 45 is -10, and 85 minus 11 is 74. Ooh, that doesn't look good. I'm pretty sure I'm not going to have a decimal. Nope. Looking at the answer key, x is or y is not 7.4. Bummer. I found my mistake. You guys probably already found my mistake. 3 times b. So 3 times b is 15 and 9. I don't know if I can erase this. Nope. And then 3 times 11, I don't know what I was thinking here, is 33. See why it's so important to really be clear when you show your work. I have 35 minus 9 is 26y, and 85 minus 33 is 52. That's better. Y equals 2. Yay! And that is correct. I can plug it into either A or B. 3x plus 14, which is 7 times 2, equals 17. 3x equals 3, x equals 1. And then last but not least, let's plug it into one of these equations. So 4 times 1 minus 2 minus z equals negative 1. Negative 1 minus 4 plus 2. Negative z equals negative 3. Z equals 3. It's glorious. Write your answer in alphabetical order. X, Y, Z. Isn't that wonderful? Okay, there are 2 exercises, 4 and 5, and then we're done because it takes so long to work through these. If you'd like to do this one on your own and check your work, that's great. The next one is a parabola, so I need you definitely to look at number 5. Cool? So just like yesterday, just like the last example, yes, I did record half of this one day and half the other, so it was yesterday to me, but it's the same video to you. I'm going to number these things just to see if it helps you track the work better. So I'm going to add equations 2 plus 3, and I think I'll be able to solve it pretty quick if I do that. Oops. R. So if I add these 2 equations together, I'm left with R equals 6. Yay. Let's see. And then maybe if I add 1 and 2 together, now that I know what R is, 6 plus 2x plus u equals 8. And s plus u equals 4. There's a typo here. That should be an s. We are not doing equations with 4 variables. Okay, and this should be a minus. So that'd be 6 plus 2s minus u equals 8. We're going to add these together. I have 6 plus 3s, the u's cancel, equals 12. Subtract 6 from both sides. Divide both sides by 3. So we have s equals 2. Let's just use equation 2. I have 2 plus u equals 4. Subtract 2 from both sides. And then you should write them in alphabetical order. And you have your answer. Cool. Okay, last example. Find the equation of the form y equals ax squared plus bx plus c, whose graph passes through those 3 points. So all 3 of these points are giving me x, y points, and we're trying to find a, b, and c. It's a parabola, so we're given x and y. If you would look at it, something like that, we're given 1, 6, 320, and negative 2, 15. So we need to find a, b, and c. So we'll have 3 equations. Let's go ahead and plug our x, y in. First of all, we have y equals, x is 1. So we're doing the 1 comma 6. So a times 1 squared plus b times 1 plus c. Then we can do 320. 20 equals ax squared. So 3 squared is 9. Oh, I did that backwards. So I plugged 3 in for x, and I got 9a plus 3b plus c, and then negative 2, 15. Negative 2 squared is 4. Negative 2b and c. So we need to solve this. Okay, I'm not going to go through an example. We all work these different, so for you to look through my example to see what I did is sort of silly. But if you'd like to go ahead and try it, you can check your answers. And C equals 5. So my equation is y equals 2x squared minus x plus 5. And you can go ahead and plot this in your calculator and then plot the 3 points, and you'll see that they overlap each other. It's pretty cool.